when you picture an emergency response, you usually think of something loud like big red fire alarm handles, glass you have to break with a tiny hammer, sirens wailing in the hallways.
Right, yeah. It's designed to be completely unmistakable.
Exactly.
Because the physical design forces you to commit to the action, and everyone around you knows exactly what's happening.
But today, we're looking at a completely different kind of emergency trigger, one that is utterly silent, entirely hidden, and relies on, invisible digital pathways rather than a blaring bell.
It's a total shift.
So, welcome to today's deep dive. We're looking at a product page from HDTV Supply for something called the Advanced Network Devices IPBTN Smart IP button. And our mission today is to explore how a tiny, discrete physical button translates a single human action into a massive, facility-wide digital emergency response.
It perfectly captures how the physical and digital worlds are colliding in security tech right now.
Okay, let's unpack this.
Yeah.
Picture the classic bank teller's silent alarm from, every heist movie ever made.
Oh, yeah. Reaching slowly under the desk.
Right. The teller presses a button, and the police are on their way without the robbers knowing. Well, the IPBTN is essentially the modernized digital version of that. It's marketed as the smallest IP button on the market, designed to be mounted discreetly under a desk or a table.
But the real trick is the power source.
Yeah, it doesn't need a separate power supply. It just piggybacks on existing data infrastructure.
It uses PoE, or power over Ethernet.
Okay, so it just plugs straight into the network.
Exactly. That means it can draw its power up to 300 feet away on just a standard network cable. I mean, the logistical brilliance of PoE for security devices is immense.
Because you don't have to tear up the walls.
Right. By utilizing existing IT infrastructure, the exact same cables providing internet to the computers sitting on those desks facilities can deploy these emergency triggers without hiring an electrician to run new high-voltage line. You just plug it into the network switch.
So the physical setup is brilliant because it utilizes the cables already in the walls. But pushing a button is ultimately just closing a tiny electrical circuit.
Yeah, just a small physical connection.
So how does that tiny electrical blip actually tell an entire school's PA system to go into lockdown?
Well, think of it like dropping a pebble in a pond, but the pond is the building's IT network. That one physical press is the pebble.
Okay, I'm with you.
It sends out an HTTP request. That's basically the same underlying mechanism your web browser uses when you click a link on a website, but instead of loading a picture, that request ripples out to the central server.
Oh, wow. I'm looking at the specs here, and it mentions it's SIP-enabled and integrates with third-party software like IP clockwise. Does that mean pressing this button is basically telling the server to splash automated commands out to the rest of the building?
Precisely. SIP stands for Session Initiation Protocol. You can think of it as the digital switchboard operator of the internet.
The switchboard operator. Got it.
Yeah, it's the standard protocol that tells different devices how to start and end a communication session. So that initial ripple from the button tells the SIP switchboard to automatically call a programmed phone extension, play a pre-recorded message, or tell IP clockwise.
Which is the mass notification software.
Right, to broadcast a lockdown command to every phone, digital clock, and PA speaker in the facility.
Here's where it gets really interesting, because I'm looking at the price tag. It's $275.62.
Which is pretty cheap for enterprise hardware.
Exactly. And the setup is described as just using a simple web interface or a configuration file. If a building-wide lockdown is managed by a basic web interface running over standard HTTP, isn't there a massive cybersecurity risk here? I mean, what's stopping a novice hacker from finding a default password on that simple interface and triggering a massive false alarm?
What's fascinating here is that exact tension. You have this massive industry push for accessible, user-friendly setup in IT hardware.
Everyone wants plug and play.
Right. But it's colliding with the incredibly heavy responsibility of a device that is literally marketed as something that saves lives. The simplicity that makes it easy to install is the exact same simplicity that exposes it to network vulnerabilities.
That makes total sense.
It requires rigorous administrative protocols so someone doesn't accidentally lock down a hospital while just trying to update an IP address.
And that collision between high-stakes security and everyday IT really hits home when you realize this is just a product bought online. I mean, you literally just click add to cart and check out.
Sitting in a warehouse right alongside HDMI cables and TV wall mounts.
Yeah. There's actually a customer review highlighted right on the product page from a guy named John M. He bought this life-saving lockdown button, and his main takeaway was that the HDTV Supply staff was, quote, less than friendly, but ultimately answered his questions.
Oh man, I know, right?
That perfectly grounds this technology in the mundane reality of everyday e-commerce. Even a critical network device capable of locking down a school is subject to normal customer service gripes.
It brings the sterile, abstract world of network security back down to a distinctly human level.
So what does this all mean for you? I think the biggest takeaway from this deep dive is that physical security and IT networks are no longer separate domains. They are entirely fused. A physical lockdown now relies on the exact same infrastructure that routes your emails and loads your web pages.
This raises an important question about how we design building safety moving forward. It's a complete paradigm shift.
It really is. And it leaves us with something pretty heavy to think about. If a single IP button relies on standard SIP and HTTP protocols to initiate a life-saving lockdown, what happens when bad actors decide to target the network infrastructure these emergency devices depend on? That big red fire alarm on the wall might be loud and obvious, but at least it doesn't need a firmware update.